What cameras take 128 pictures a second?
How will a wire stripper help a little girl's hearing?
Where does a mechanical chicken do a full day's work?
What businessmen are giving ducks a better break?
Industry on Parade. A brand new look at our America. Produced on film each week by the National Association of Manufacturers.
Industry on Parade turns its cameras on one of the companies that have made American motion pictures the finest in the world. It's a company that manufactures cameras, Mitchell Camera Corporation of Glendale, California. If you're a home movie addict, you're not likely to become a customer, for the cameras made here range in price from $4,000 to $18,000 each. Needless to say, they're used only for professional film production. Let's go inside and see some of the operations that can make a comparatively small piece of equipment cost $18,000. First of all, production is limited to about 200 units a year, because despite a great deal of modern machinery in the plant, most professional cameras are largely custom-made. The job involves handwork of the sort that requires many months of practice before you're even ready to try your skill. For if some part doesn't function properly, it could ruin film whose production costs run to as much as $1,000 a second. In a high-speed camera, film is brought into position, registered perfectly behind the lens, locked in place, exposed, unlocked, and moved down to the next frame 128 times a second. So all the little moving parts must not only be rugged, but machined to tolerances not even required in watchmaking. The company makes almost all the parts itself, from fine tool steel, specially heat-treated for wearability. Another reason for the need for precision work is the fact that pictures taken in these cameras will be only a little more than ½ an inch high and less than an inch wide. Yet they must be projected with perfect clarity onto a screen 50 feet high and 70 feet wide. It takes 2 weeks to assemble the camera, making sure each part is perfect as they go along. And what do they do when it's assembled? Take it apart again to clean it and reassemble it. The second assembly takes a lot less than 2 weeks, however. The magazines that hold the film not actually running through the camera are lined with velvet to prevent rubs or scratches. Those are just a couple of the bugaboos of the filmmaker. Another is extraneous noise on the soundtrack caused by the camera itself. And that's one problem they have really licked, with a thoroughly sound-insulated case called a blimp that fits over the outside of the camera. The motion picture camera, invented by an American named Thomas Edison, developed by the Germans and French, and now raised to its highest peak of accuracy and efficiency again by Americans, who use it to present the picture of life in this country to all corners of the world.
Nowhere on earth do people have the freedoms we Americans enjoy in this land of ours. Here in America, we're free to attend the church of our choice, to change jobs if we so desire. Our children attend schools which teach individual freedom. In this country, we listen to radio and television and read newspapers and periodicals which are free of government dictatorship. None of these things are possible in countries where socialism has chipped away or communism has destroyed freedom. All of us must remember that freedom is indivisible, and it is our duty to help keep America free.
Picture of a child hearing the human voice for the first time. Until now, she couldn't form sounds because she had never heard any. The machine, by amplifying speech tremendously, helps her learn to speak. One answer by America's hearing aid manufacturers like the Mako Company of Minneapolis to the problems of the hard of hearing. Here we see the painstaking assembly operations required in putting together the hundreds of almost microscopic parts that must be crowded into a hearing aid. Very few persons are totally deaf, and as long as there's any hearing whatever, sounds can be amplified sufficiently to cross the barrier of damaged hearing and reach the brain. That fact was established years ago. Now the continuing challenge to the hearing aid makers is to turn out a product that's ever more powerful and at the same time more minute. In addition to being small and powerful, a hearing aid has to be put together to withstand shock, vibration, and humidity. And overall hangs the competitive problem of holding down costs. All things considered, it's quite an order, but it's being met. The various sub-assemblies come together now to be carefully, securely installed in the outer case. One of the big changes in recent years has been the substitution of tiny transistors for the bulkier vacuum tubes. Not only do the transistors take up much less space themselves, but they also require far less power, which means the substitution of dime-sized energy capsules for batteries. Everything used in giving hearing to those who do not have it is tested endlessly before and after it goes into the instrument. Actually, the company's specialty has been the making of acoustic instruments for the medical profession, instruments to test hearing, so they're well equipped to determine whether their own products are up to the standards demanded. Here, research into the science of hearing goes on without interruption. In a completely soundproof room, suspended in midair to cut off vibrations from outside, an audiometer shows exactly to what extent a person's hearing is impaired. And a device called a chromalizer converts sounds into colored light patterns, allowing our little girl learning how to speak to imitate the words she hears until she duplicates the pattern on the screen. This must be a satisfying business indeed.
Wooden ships a-building in Maine. They're not all wood, though. Every vessel carries at least some metal, if only in the screws that hold its planking together. To learn something of how screws are made, Industry on Parade visits the Continental Screw Company in New Bedford, Massachusetts. Most sizes of screws are made from one thickness of wire, which is drawn out to the proper diameter for each batch. Passing through a straightener, the wire enters the heading machine, which cuts it off to the proper length and puts on the head. They slow it down so that we can see a little better how it works. First, it mashes the end of the wire into a blob, then shapes that blob into a rounded head. Back to normal speed, which is too fast for the eye to follow. Before and after. Next step is to put the slot in the head for the screwdriver to engage. As you might imagine, the slot is cut by a saw. Now we're ready to taper the screw and thread it. The blanks are picked up and fed into the threader like this. And as each screw is finished, it's pulled out by what looks like a rooster with a one-track mind. And that's about it, except for inspection. There are innumerable shapes and sizes, head contours and slot widths, and different kinds of metals. But basically, we've seen how most screws are made. And how are they measured out? No, they're not counted. They're weighed, just as nails are. Watch how she opens and closes the box with one hand and pours with the other. Part of the reason why these tiny metal screws are plentiful and inexpensive in this country as nowhere else on earth.
Older workers represent countless years of rich and seasoned experience, judgment, and stability, and constitute an immensely valuable asset in the nation's workforce. American industry urges all employers to observe voluntary hiring practices which give consideration to skills and abilities rather than to any arbitrary age factor. The problem of determining proper retirement ages requires continuing study, since conditions vary with companies, jobs, and individuals.